Interhalogen compounds. When halogen react with another halogen form compounds are called interhalogen compounds. They form X X dash X X dash thrice X X dash 5 X X dash 7. This type of interhalogen compounds where X and X dash both are interhalogens. X is larger size atom or more positive halogen. X dash is smaller size atom, more electronegative halogen. Preparation of these interhalogen compounds. Cl2 plus F2 fluorine limited amount we take gives rise to 2ClF. Br2 plus Cl2 gives rise to 2BrCl. Cl2 plus 3F2, if we take excess of fluorine, then it gives rise to 2ClF3. Br2 plus 5F2, excess fluorine taken, then gives rise to 2BrF5. I2 plus 7F2, excess of fluorine gives rise to 2IF7. Br2 plus 5Cl2, excess of chlorine gives rise to 2BrCl5. These are the preparations of the interhalogen compounds. Their hydrolysis reactions. Hydrolysis. During hydrolysis, smaller size atom is always converted to X dash is smaller size atom, it always converted to halide, and larger size atom X converted to hypohalite in case of X dash hydrolysis. X converted to halite in case of X dash 3. X converted to halate in case of X dash 5. X converted to perhalate in case of X dash 7. For example, hydrolysis of ClF3, which on hydrolysis 2H2O it gives rise to 3HF plus HClO2. ClF3 means X-3 type of interhalogen compound, where X dash is fluorine, it converted to halide, fluoride. And larger size atom X, that is Cl here, it converted to ClO2 minus, its name is chlorite. So larger size atom converted to halide. Types of interhalogen compounds, that is X dash, X dash thrice, X dash 5, X dash 7. Examples for this X dash example ClF, BrCl, ICl, and so on. X dash 3 example ClF3, BrF3, Cl, ICl3, and so on. X dash 5 example BrF5, BrCl5, ICl5, and so on. For this example IF7 and ClF7, BrF7, and so on. These are examples. Electronic configurations of the central atom. Electronic configuration NS2, NPX2, NPY2, NPZ1. In these, hybridization is absent and electron pairs, it contain one bond pair and 3 lone pairs, and the shape become linear. For XX dash type interhalogens, shape is linear. Here electronic configuration of central atom Ns2, Npx2, Npy1, Npz1, Nd1. Here three bonds are formed by X. To form three bonds, one electron is in excited state. The hybridization takes place is sp3d. It forms three bond pairs and two lone pairs. It contains three bond pairs and two lone pairs. Shape become a T shape. Here Ns2, Npx1, Npy1, Npz1, Nd1 and Nd1. Here hybridization is sp3d2 and contain 5 bond pairs, 1 lone pair. Shape is square pyramidal. In case of this one here, central atom form 7 bonds, so this electron is also in excited state. The largest size halogen is in third excited state. Ns1, Npx1, Npy1, Npz1, Nd1, Nd1, Nd1. Hybridization is sp3d3. It contains 7 bond pairs and 0 lone pair. Shape is pentagonal bipyramidal. These are some important points about the interhalogen compounds. For example, ClF3 structure. It is XX-3 type of halogen. For this shape is T shape. So Cl, it undergo hybridization sp3d. So electron pairs and bond pairs oriented in trigonal bipyramidal geometry. Two positions are occupied by lone pair, remaining positions are occupied by bond pairs. So it has T shape. For example, BrCl5. It is a XX-5 type interhalogen compound. Their shape is square pyramidal. Undergo sp3d2 hybridization means geometry octahedral. One position is occupied by lone pair, one axial position occupied by lone pair, remaining all positions, 4 equatorial and 1 axial positions, these are occupied by Cl atoms. This shape is known as square pyramidal. Next, IF7. This one is XX-7 type of interhalogen compound. Their shape is pentagonal bipyramidal. Contain total 5 equatorial positions. These are the 5 equatorial positions and 2 axial positions. All these positions are occupied by fluorine atoms. So these are some important points about the interhalogen compounds.